Hello friends, welcome to this video. This video is about first law of thermodynamics, which I am sure all of you are aware of. But in this video, I am going to talk about definitions along with some important features of this law, you can say, which interview picks to trouble you. So watch this video carefully so that you can answer them easily. So let's start. What is first law of thermodynamics? It is also called law of conservation of energy. You all know that. It states energy can neither be created nor be destroyed, rather, it gets converted from one form of energy to another form. Okay, so energy of entire universe is constant, just it converts from one form to another form. That's all this law of conservation of energy tells us. So, if we talk in thermodynamic terms, means system, surrounding, process, if we talk in those terms, the interpretation of law of conservation of energy can be stated as, for a closed system, I have underlined certain terms, so you should emphasize on them. These are important terms. For a closed system undergoing a cyclic process, the net heat interaction is equal to net work interaction when they are expressed in their own units. Okay, so first law of thermodynamics is defined for closed system. Second, for cyclic process. Third, the heat interaction and network interaction are equal only when they are expressed in their own units. For example, if we express work in kilojoule while heat in kilocalorie, they are not going to be equal. So it is necessary that they are expressed in their own units. Okay. Also, again, this is very sensitive topic. Examiner hits this topic almost every time when he asks about first law of thermodynamics. People mistake generally that first law of thermodynamics is for reversible process. Here it is written for a cyclic process. It is not a reversible process. It can be applicable for reversible process as well as irreversible process. So you must understand this. For a closed system undergoing a cyclic process, this much is written in first law of thermodynamics. No mention of reversibility. Okay, so if he says, okay, tell me if first law of thermodynamics is valid for reversible process or for irreversible process or for both. So you would say it is applicable for both. Okay, so this is the mathematical form of first law of thermodynamics. This we are going to prove it just in a second, but you must understand this first, that dq is net heat interaction, dw is net work interaction. Now why this sign is written over d? We generally write, for example, dt, dp. So why this d bar is written? It is called as d bar. So why this is d bar? This is because heat and work are path function. They are not point function. There are two terms, point function and path function. So point functions are exact differentials, path functions are inexact differentials. So inexact differentials are denoted by d bar, while exact differential like temperature, pressure, they are represented by d. Okay, so I hope you understand this. Now coming to the part of mathematical expression of first law. But in order to proceed further, we need to adopt some sign convention first. So in thermodynamics, what is general sign convention? Heat supplied to the system is positive, heat extracted from the system is negative, work done on the system by surrounding is negative, work done by the system on surrounding is positive. Okay, so this is the sign convention and you should keep that in mind. Okay, next coming to this mathematical form of first law of thermodynamics. So you know this is energy conservation principle. So applying energy conservation principle to get the mathematical form of first law of thermodynamics. So we can say heat or work supplied to the system means they are system and surrounding, they are having energy interactions. So for conserving the energy, we can say what's the energy input must be energy output. So energy input can either be in the form of heat or in the form of work. So we say heat or work supplied to the system is equal to, now system energy, how can system gets the energy out from it? System. Now if we supply energy to system, so its energy will increase. So change in energy content of the system due to supplied energy. So heat or work supplied to the system. So heat supplied to the system, as we saw in sign convention, positive. Work done on the system, as we saw in the sign convention, negative. So heat or work supplied to the system becomes dq minus, becomes d bar q minus d bar w, and change in energy content of the system. Change in energy content of the system becomes du. This is new term du. Du is change in internal energy. Internal energy, as we'll see in the next lecture, what is internal energy? Internal energy is microscopic form of energy, and it is the property of the system. So I hope you got the first law of thermodynamics. Again, for summarizing, we can say first law of thermodynamics states for a closed system undergoing a cyclic process, the net heat interaction is equal to the net work interaction when they are expressed in their own units. So some special features are no mention of reversibility is there in the first law of thermodynamics. It is defined for closed system, cyclic process, and when heat and work are expressed in their own units. So this brings me to the end of this lecture. Thank you very much for watching this. If you like this video, hit the like button and don't forget to subscribe to this channel. Thank you.